All right, guys. Bruce, what's going on, Bruce? Okay. All right, so glad to see you guys are here. I think if the live stream isn't working for you, then just go ahead and watch it on your phone. That should work as well. So, I mean, obviously the screen's not as big, but you can still see what's going on through there. All right, so I got about 10 people on right now. I think I'm gonna wait just a little while, maybe about 2 more minutes, just for everybody to come on in. So while you guys settle in, I'm gonna show you. You can. Is the sound not good right now? Let me know. All right, I'm gonna go ahead and get started. So the worksheets that I'm gonna be working through. Hey, Jody. All right. So the worksheets I'm gonna be going through. Let me just show you. They're on Schoology. So if you hop over to period 5 under online week 1, you'll see both of them right there. So in the event that you want to watch now and then take notes on paper, or if you want to go back later and actually print these out and then you know fill it in yourself, remember that you can use notes on your exam, on your test. So I would recommend you, if you get a chance, to print it out, and so you'll find it on Schoology. So here's the first one that we're going to go through, and then the second one is there as well. So this is the second part, right? So the constructive response, and we'll take a look at this like second half. Yeah, so it's all there. Okay. All right. So let's go back. It sounds okay, but it's lagging. Sound is okay, but there's a lag. It's lagging a lot. Yeah, there is a lag. There's a significant lag. Let me close some of the things that I'm not using. Hopefully it helps. All right. I'm gonna go ahead and get started then. So keep me posted if if it continues. I'm sorry for the lag, but the video, um, I don't know what's going on. Maybe because I have the webcam showing this time. I didn't have it like this earlier, and it seemed to be working okay. But I know that there's like about a 15-second lag, if not more. Um, that's just how the OBS is transmitting my signal right now. All right. So let's go ahead and get started. So for this one, this is kind of like the last set of formal notes before the end of the unit, and then there's the constructive response. So kind of starting off with what we have here, it's a little bit of a like a step backwards with what we've seen. So if you take a look at the 4 different inequalities that you're given, notice how these are slightly different from what we did last time. When we left off, we took a quiz, right? And we looked at inequalities that had maybe like x's on both sides. So your job was to push everything to one side. These are different, okay, because now they both have x and y. So pushing everything to one side is kind of useless. The goal in this case for this particular set of problems is to get them into y equals mx plus b. Yeah, that would be nice. So starting with this setup, we want to go ahead and get everything into y equals mx plus b. So the first thing you want to do is for the first one, right? Notice I have a 2y, so I want to get rid of that 2y. So I would divide everything by a 2. Okay. When that happens, right, the 2's cancel, so now we're left with y is greater than or equal to x over 2. And then minus 3 over 2. Well, 3 over 2, that's the same thing as 1.5. Okay, so I'm going to leave it as 1.5 because it's a little bit easier to graph. All right, so now I have my equation. And I'm going to go through and just convert everything first into y equals mx plus b, and then we can graph them. Okay, I think that might be a little bit better than going back and forth. All right, so now next one, similar idea here, right? I want to try to get the y by itself. So a couple things that would need to be done because I need to move the x first. So I subtract x. So that's gone. Now you're left with a negative 2y is greater than or equal to negative 7 or negative x minus 7. All right. In order to then get the y by itself, we divide everything by negative 2. All right, so from there, we can get y. Because you divided by negative 2, remember that the inequality flips. So now that flips. Negative divided by negative, those cancel. So then you can just bring down x over 2. And then here you have negative 7 over negative 2. Again, those negatives cancel. It becomes a positive. And then finally, 7 over 2, that becomes 3.5. All right, so now if we keep it moving, the next one is already good as is, right? Y is less than or equal to negative 2x plus 6. It's already in mx plus b form, right? So we can go ahead and leave that one alone, and we'll move on to the last one. Okay, so now for the last one, all right, what do you think could be the easiest way to get back to y equals mx plus b? Notice how you have 2x and y already on the same side, so maybe just by moving the 2x, right? If we can move the 2x to the other side. Okay, so now y is by itself because the 2x cancels on this side. Inequality stays the same, right? And then now we have negative 2x minus 9. So now I can graph all four of these, all right? So going back with the orange one, all right? In this case, notice how my intercept here tells me to start at negative 1.5. So that's going to be negative 1, negative 2, right in between. I have a point right there in the middle. Okay. From there, I have to then notice what is the slope here. Well, the slope is x over 2. Well, since there's no number in front of x, I can draw an invisible 1. So that means I have a slope of 1 over 2. So I rise 1. Remember, slope is rise over run. Okay, so 1 over 2, I rise up 1. So remember, it's not going to go it's not going to go just up here to the dotted line or the dashed line and stop. You got to go a full step. So it goes up here and then run 2. So you end up right there. And then let's do that a couple more times. Go up a full step and then run 2. And then one more time. Okay, so up 1 over 2. Okay, so then from there, carefully draw a line. So let me see if I can do that here. I don't have my stuff from school, so I don't have any rulers at home. Alright, so I'm gonna try my best here. Actually, wait, there's gotta be something. Okay, so there's my line. That looks okay. And because it's an inequality, now we got to go back and we got to shade one of these sides. So if you're asking like, okay, it's a line, notice that it's supposed to be a solid line because it's greater than or equal to. Okay, now if it was just greater than, then you could have done it. It's supposed to be a dashed line, but because there's an equal sign underneath, then that's a solid line. Okay, I'm gonna just draw over it because I want it to be all the same color. All right, so once you have the line down, then it tells you you have to shade. You have to shade either above the line or below. So because of the inequality, because it starts with y is greater than, right? Greater than means above. If I'm above something, then I want to go ahead and shade above this line. Or if I'm greater, I want to be above the line. Okay, so I'm shading in this area here. Okay, this is a little bit of review from like Algebra 1, maybe even a little bit from the beginning of this year. Okay, so I got the first one down, and then now we can move on to the next one. Okay, so now next one, right, in purple, I know that the starting point here is 3.5. So 3.5 is going to be 1, 2, 3, and then a little bit above that. Okay. All right, so there's my coordinate, there's my y-intercept, right? That represents your b, that's your starting point. Okay, and then the same thing, right? Notice how they have the same slope as the other one. Since this one also doesn't have a number right in front of the x, I can draw an invisible 1. So now I have a slope that's rise 1, run 2. Okay, so from this point right here, 3.5, you can go up 1 and then run 2. And then you can go ahead and do that again, up 1, run 2. And then up 1, run 2. Okay. So let me draw a line here. Okay. And let me just trace over it real quick. Whoa. Let's try it one more time. All right, so there's the line. And now take a look at the inequality this time. The inequality is less than. Y is less than. So because it's less than, then you want to go underneath, right? Anything that's less than, it's under. So you go under the purple line now and you start to shade in purple under that line. All right. So now let's go ahead, let's move on to the next one. Next one, let's try a different color here. Let's try lime green, okay, for this one. All right. So far, notice that there's a little bit of an overlap section where they both have orange and they both have purple, right? So we're talking about this middle section right in between the lines, okay? Now we're going to include 2 more lines, and eventually the goal is to find out what is that section that has all of the colors, right? What is the feasible region? That's what we call it. It's a region that every graph has an overlap, all right, where they all overlap. So starting here, we have a point that goes and starts at 6. So this was 3, that's 3.5, so that's 4, 5, 6. So I have a point here. And take a look, right? It's -2. There's no number underneath. So just like you added 1 when there was no number, like for example, there was no number 1 here and you added it. Well, you can go ahead and include a 1 underneath so you can create a slope with a rise and a run. So now you want to go down 2 and to the right 1. Down 2 to the right 1. Down 2 to the right 1. Okay, and so now you have a couple of points there, and you can go ahead and sketch your line. All right. And so then from there, you can go ahead and say, all right, it's less than, right? So less than means below. If I'm below, well, think of this green line as like the roof of a house, right? Where would you want to be if you're going to be under the roof? Well, it doesn't make much sense to be in this area, right? So you want to be underneath the line. So then everything that's basically to the left of the line counts as below. Okay. So now we're starting to create a more defined section where everything overlaps, right? Right around here, you got purple, you have orange, you have green, right? Right, all of this middle section, okay? So now the last one to consider is this blue one, all right? So if you go ahead and you start at -9, right? This one's written a little bit backwards. So how about we rewrite it first so that it becomes a little more clear what it's going to be, whether it's going to be less than or greater than. So I'm just going to move y to the left. All right, now look at the inequality. The inequality, the mouth is open to the y. So when I rewrite it, I need the mouth open to the y. All right, and then I can rearrange this part and write it as -2x -9. Okay, so now it's a little bit clear to see whether you're going to be shading right to the right, above or below, because now you have the y on the left side, so it's easier to read. All right, so now let's go ahead and graph it. If I have negative 9, then I have a point way down here on the graph. Okay. And then, let me see, my slope is negative 2x, so I can put a 1 underneath. All right, now that slope is telling me I need to go down 2 and to the right 1. But if I do that, right, I'm out of space. I don't have anywhere to go down to. So I want this to be accurate. So you guys know that if you go down 2 and to the right 1, it's the same thing as going up 2 and to the left 1. Right, you go backwards in both directions and your slope still continues, right? Look at that line. It's still going to be pretty consistent. All right, so we're going to go up 2 instead and to the left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Okay. All right, so from there now I can sketch this up and we can finish this up. All right. And now finally, let's graph, right, that final piece. So it's saying that y is greater, right? Y is greater, that means I want to be above the line, right? Or in this case, it looks kind of like to the right, right? Think about it again as a house. You have the blue line as a roof. If you're underneath, right, you're under here. If you're above the roof, you're standing up here. So that means you want to shade everything above it. So now what you have is this little section right here. I'm going to go back and highlight it, but you have this section that essentially tells us where all 4 of the colors make intersections, right? So right around this edge right here. So everything inside of that. Okay, represents the solutions to this system because that's where all 4 of the colors show up. You have orange, you have purple, you have green, and you have blue, right? Everywhere else, you're going to have a missing color. All right. So that represents this right here. You have to label this. You have to call it, right? Make it very obvious right here. Put a big arrow. Okay, that this represents the feasible region. Okay. It's the region on the graph where everything is going to be a true statement, right? Any point that you pick inside of that is going to be true for 1, 2, 3, 4. Okay, so for all 4 functions, you're going to get a true statement if you pick a point from inside of that area. If you pick a point outside of that area, anywhere else, and let's say you pick a point out here, it's only going to be true for some of them, but not all of them. Okay, so you want the area that represents true for everything. Okay. All right. How we doing? We're okay? Let me know if there's any questions. Just feel free to put them on the chat. Okay, so then if you take a look at part A and part B, then you see that there's these 2 questions, right? For part A was asking what type of polygon is formed by the solutions of this set of inequalities, right? So take a look at, the yellow, right? What kind of shape does that look like? Well, maybe not so much like a square, but at least it looks like somewhat of a rectangle, right? We can at least determine that it has 4 sides, right? So at least we can say that it's either a quadrilateral Okay, maybe a rectangle. Okay, so those are our options. All right. The next thing would be to find the vertices on the polygon. Okay, now the vertices are essentially where the lines all made connections, right? So think of like a vertice of a shape, right? Let's like if it was a triangle, the vertices would be these points where all the lines connect, right? So in our case, you can see closely, right, that I have a point of intersection here. The green line and the purple line looks like it's right here, right? I have one right there. I have another point right here between orange and green, right? Those two make intersections right there. Then we get another point right here between blue and orange. And then the last one would be right here. You don't get the shading. Okay, so let me break it down real quick down here. You gotta start like, so let's say something simple, right? So y is greater than x plus 2. You have to read this inequality here. Starting with y, start with y. So y is, and then you read this, right? So because the mouth is open towards y, you say greater than or equal to, right? If it's greater than, you shade above the line. Okay, so let me just sketch something random down here. If I had a line that was at 2 and a slope of 1 over 1, okay, if I sketch that line out, if I'm greater than, right, y is greater than, then I want to shade above the line. I don't want to be down here. It wouldn't make sense to be here, right? Because there I can see that if I put a person down here, where are they? They're under the line, right? That's not what you want. You want to be above the line, right? So you could literally stand on the line, right? So you're greater than that line, so you can shade everything in this direction. Okay, as long as you're above the line. Okay, how do you determine the type of polygon it is? Okay, so the type of polygon, let me erase this triangle because that's a little confusing. Well, basically, I'm just looking at the shape of where the answer comes from, right? So the answer for this part is everything that's shaded overlapped, right? So I'm looking at only this piece. Well, if I were to kind of draw that out, this is what I get, right? So I mean, it's trying to make a connection to geometry. It's really not like, it's not super important, right? But basically it's like, what is the shape? A polygon is just what is the shape, What type of shape is formed by the solutions? Well, the solutions create this rectangle, this box right here. Okay, so it's pretty much a quadrilateral is just any polygon with 4 sides. So I can list it as a quadrilateral, but more specifically, it's probably just a rectangle. It's just a regular rectangle, right? I could tell that these two sides look pretty much the same length. These two sides look like they're the same length. This is probably a 90 degree, right? We don't know exactly, but that's the idea. Okay, so I hope that helps, and then we can try to move on. All right, let me erase this. This was just like a little baby example. Okay, so now these 4 points that I highlighted, right? These really dark ones. Okay, those are the vertices. Okay, those are the vertices. Those are the points where the lines make connections. Okay, so basically we just want to list those points right around here. So where do they make connections? I can see, well, then here it would be 1, comma 1, 2, 3, 4, right? So 1, comma 4 is a vertice of the rectangle. Okay, the next point looks like it's 1, 2, 3, comma 0, right? That's this one right here. The next point that looks like this big dot down here would be -1, -2, -3, down 1, 2, 3, so -3, comma -3. Okay, and then finally this last one right there, that's going to be -1, -2, -3, -4, -5, up 1. Okay, so these 4 coordinates, they represent the vertices. Okay, vertices of the polygon. All right, so that's pretty simple. I guess, again, the big idea is just, right, shading in the right spots, right, above or below, and then determining, what is the area where everything overlaps, right? So for us, it was this rectangle here in the middle. Okay. All right, so let's move on now. So this is kind of like the building blocks, because this is the basics, right? This is the basics that then let us understand what comes next. So what comes next here is you have to graph now a quadratic. So notice, right, it's in the form of HK, right? Remember the standard form for quadratic is y equals a times x minus h squared plus k, right? So it's already in the form. So really what we're looking for is what's the vertex, and then we graph a couple points, we sketch it, and then we decide where do we shade. Okay, so I'm going to show you 2 ways. One where you want to think about it as like below and above, and another one where you can try it with a test point. You pick a point, you test it. If it's true, then you get to shade inside. If it's false, then that means you have to shade the outside. Okay, and then it's pretty simple. So for this particular one, what's my h? Well, remember it's opposite keep. So right now my vertex, that's telling me right now it's going to be 3, comma 1. So at 3, I can go up 1, and I have a vertex there. All right. So now what comes next is we have to build the quadratic, right? Which is like the most kind of tedious part. So really, I'm just gonna graph one extra point, and because I know parabolas are symmetric, right? You know, if you make a U shape, whatever you do on the one side, it'll match on the other side. So what I'm gonna do is I'm just gonna find one more point and then match it on the other side. So in this case, I'm gonna try to plug in. See, I've got 1, I got 2, I got 3, I got 4. So I'm gonna plug in 4. Okay, I'm gonna try to find out what is the value of when I plug in 4. I'm gonna plot it. Whatever answer I get, then I can match it over here on 2. All right, so just a little bit of scratch work right here on the side. When I plug in 4, I'm gonna get 4 minus 3 squared plus 1. 4 minus 3, that's just 1 squared plus 1. Well, 1 squared is 1, so 1 plus 1 is 2. Okay, so when I plug in 4, I get 2, so I can go ahead and put that point 4 up 2. Okay, and the same thing is going to happen over here with 2. If I plug in 2, I'm going to get the same output, right? Because it's symmetric. So I already know I have a curve that's going to go in this direction. So I just got to match it on the other side. So I can put a point there. All right. So now I can kind of see my U shape, right? Really kind of like a baby one. All right, so now notice, take a look right here. Look at that inequality, right? Notice that it doesn't have the equal sign underneath the inequality, right? There's no bar that does that. Okay, so that means that this is a dashed line. Okay, the reason why all of the other ones were solid, if you go back, right, notice they all have that equal sign underneath, right? This one had it, this one had it, this one has it, this one has it. Okay, so just remember that if it's a greater than or less than, then it's a dashed. If it was equal to, then it's solid. So you got to draw this with dash parabola. Okay, and again, it's not perfect. The whole point of this is not to like spend a bunch of time graphing these perfect, but you want to get at least a sketch that's accurate enough with the right vertex and at least 2 more points that are accurate. All right, so now this goes back to what we looked at, right? That explanation that I gave. Take a look. That says greater than, right? Y is greater than because the mouth is open towards the Y. So that just leaves you with 2 different areas and where you're going to shade. You have your inside and then you have your outside. Okay, which one of those is it going to be? Well, in this case, it's a little hard to describe it, like especially through video. But if you think about that quadratic, there's your curve, right? You want to be greater, which means above. Now imagine that you start to pull the curve apart. Where would you be above? Would you be in this area up here, or would you be down here in this area? Okay, think about it. So if that doesn't quite register, why did I choose 4? It was the closest number to 3. You can do that too. Okay, so Geraldine, it's basically like I knew my vertex was what, 3, 1. So I just chose a number 4. I found this value. I chose 2. Right, I know that these 2 numbers have to match, right? So I got 2 for this one. I knew it was going to be 2 for that one. So then that's how I got it. Okay, so going back to deciding where you can shade. All right, so you have 2 sides, right? Kind of like above and below. Think about what it means to be below the quadratic, right? If you're under the quadratic, right, wouldn't it make sense that if you're under the quadratic, it's all of this space, right? Okay. Well, there's really only 2 sides. There's the inside, which you could agree would be in here. Call that purple. And then there's the outside, which is everything on the other side, right? Even though it looks like it's starting to climb, it's on the left, right? It's on the outside of the parabola. Okay? So, if I'm greater, I want to be above. Okay? Above, in this case, would mean to be inside, right? Because if I was less than, then I would have to be underneath, right? And that doesn't quite make sense. All right. So another way to test it is to also do this, right? Like, let's say that like visually doesn't make much sense. Well, here's what you can try. You pick a point, right? You pick a point that you think might be greater than, right? So let's say I'm going to pick this point right here, right above the vertex. I'm going to pick that point. So I'm going to pick 3, 2. This is my test point. Kind of like we did test points with the other one, right? You had to take a test number, plug it in. This is your test coordinate. So you have to plug this in for your X and your Y. So right here, let me do a little scratch work. Instead of X, I'm going to plug in 3, and instead of Y, I'm going to plug in 2. The whole point is that you plug something in, and if it becomes true, then you shade the section where that point belongs, okay? So if this test point ends up being true, I got to shade everything inside as true. If it ends up being false, then I don't shade that section. I would have to shade the outside section. Okay, so plug in 3 and plug in 2. So for Y, you get 2 greater than parentheses 3 minus 3 squared plus 1. 3 minus 3, that's 0, right? So you get 0 squared plus 1, and then this is supposed to be less than 2. Well, now 0 squared is 0 plus 1, and you're left with 1. And you get this statement. 2 is greater than 1, right? That's true, right? So because it's true, then you got to shade the inside. The inside ends up being the true, okay? So you shade all of this, okay? That means if you shade the inside, that means you do not shade the outside. Everything on the outside would be false, okay? So that's one way to do it. All right. I'm gonna move on. Try out the second one as well. Okay. So here's number 2. Okay, same idea, right? You start off with a vertex form, quadratic, and right here, notice that you can take this opposite. Remember, that's your H, that's your K, but it's opposite keep. So you have a vertex that's -4, 3. Okay. So now take your point, -4, up 3. Okay, you want to try to plot that quadratic. Okay, so again, the same like I did before. I'm gonna make a t-table. Here's my X, here's my Y. Vertex is gonna go in the middle. So 1, 2, 3, -4, 3. Okay, so I can pick a point next to -4. Right, that's -4, that's -3, -2, -1. Right, so I can choose between -5 or -3. I'm gonna choose -3. Okay. All right, so when I plug that in, little scratch work here, I'm gonna have -3 plus 4. This is gonna be squared, and then plus 3. So now clean this up, right? -3 plus 4, that's 1. You square it, and then you can add 3. So 1 squared plus 3, that's a 4. All right, so then -3 has a 4. Which means that now if I choose the other side of -4, which is -5, that's also a 4. Okay, so I know that they match, right? Because they're symmetric. That's the whole point. So I put a point here at -3, 4, and then I can also put a point at -5, 4. Okay. All right, so now sketch it, right? Notice, look at the inequality. It's less than or equal to, right? It's got the bar underneath, which means solid. Okay, solid. So you draw your solid curve. All right. And now we have to decide which way to which one we're going to shade. Is it going to be above or below? Well, this one is telling me less than. Right? Less than or equal to. Well, less than probably going to be a point that's under. So let me test something. Let me test a point that's under my parabola. So I'm going to pick something here. I'm going to pick something easy. I'm going to try like 0. See how 0, 0 is like way under? I'm going to pick that point. Okay, just because zeros are easy to use. Okay. So now we test it. So you test 0, 0. All right, so now go ahead, plug everything back into that original. You're going to get 0 is less than or equal to 0 plus 4 squared plus 3. Okay, so to clean it up here, that's going to be 0 is less than or equal to, I got 0 plus 4, so that's 4 squared plus 3. And so then this is going to be 0 is less than or equal to, that's 16 plus 3, that's 19, right? So then is that true? 0 is less than or equal to 19? Yes, that's true. So you see every part that is outside of the parabola, that does not include the inside. Everything that's outside gets to be shaded. So include some of these pieces over here. Okay. So everything else is shaded. Okay. So you see how less than typically means under, right? But if that doesn't quite make sense, like, use a test point for sure. Okay. Which means that if you would have tested the inside, you would have got something false. That means you don't shade inside. Okay, so leave that piece alone. All right. All right, I'm gonna keep going. So let me slide down a little bit. Okay. All right. Now these two is just more of the same. Okay. Example 3 and number 4. So I know I don't want to go past like the typical time that we go in class, because I know you guys have like other teachers asking you to do different things. So I'm gonna just leave these two for now. When I upload the notes, they'll be done. Okay. But I don't want to spend too much time on the video for it. All right, so I'm gonna move down, and in fact these are just like additional practice. So what I would have done in class is like after those first two I would have said, okay, try these two on your own. Okay, so let's just pretend like we did that. All right, so now for example 5 and example 6, okay, these are the important ones. Okay, so now you have a system of inequalities. A system, why? Because now you have two, right? There are two equations, which means you have to graph both. One of them, notice, is a parabola, right? It's a quadratic function. Okay, so you're going to get a parabola shape from it. Now the other one, notice it does not have any powers, which means, right, it looks like some of the equations we had at the very beginning. This line right here, well, I'm sorry, this equation represents a line, but it's not in mx plus b. So we have to convert into y equals mx plus b for it to make sense. Okay. All right. So let's go ahead and start with the line. Let's rewrite it first. Let's graph it, and then we'll do the parabola. Okay. So here, notice that I need to have y by itself. So I need to do a little bit of transformation. So I got to subtract 3x from both sides. That's going to give me, I'll keep going over here, 2y is less than negative 3x plus 4. Okay, from there, got to divide everything by a 2. All right, so then when those cancel, y is going to be less than negative 3 over 2x. plus, well, 4 over 2 is just 2. Okay, so now that's ready to graph. So we got to go put a point at 2. And then you got to go down 3. So down 1, down 2, down 3, and then to the right 2. Okay, do a couple more times. Down 1, 2, 3, over 2. I'm going to go backwards now. Go up 1, 2, 3, and to the left 2. Okay, so those are my dots. That represents my line. Now take a look, right? Look at the inequality. It's only less than. So solid or dashed? What do you think? It's got to be dashed, right? So dashed line coming through. Okay, and with the line, it's real simple, right? This represents less than. Less than means under. Under the line is going to be down here, okay? I'm not going to shade it in just yet because I want to graph the other one first. But just know, right, that we are eventually going to shade the bottom half of the graph, okay? All right, so now the parabola, let's go ahead and graph that one. I got it different color here, so let's go with green. All right, so notice my vertex, that's opposite keep. So my vertex in this case is going to be 1 comma negative 3. So at 1 negative 3, there's my point, okay? We can use test point now to find another point on the parabola, okay? So let's go ahead and do that. You can make a little t-table over here. Okay, so then if my vertex is going to be 1 negative 3, then I can pick 0. Let me plug in 0. All right, so if I plug in 0, I'm going to get 0 minus 1 squared and then minus 3. All right, so then here's what I got. That'll be a negative 1, but I got to square it, and then minus 3. So negative 1 squared is 1 minus 3. That's going to be negative 2. Okay, so that means like 0, it's negative 2, which means that at 2, it's also negative 2. Okay, so we can put a point here, and we can put a point here. All right, so now quadratic, now we can sketch, right? So quick sketch. Remember, look at the inequality to determine whether it's solid or dashed. In this case, it's a solid, so we go ahead and draw solid. All right. Okay, so like we said before, right? We knew that with the red line, we knew we were going to be shading under, right? So I'm going to shade underneath because it's less than. Okay, so everything down here under the line gets shaded. Okay. Now for the green parabola, right? We need a test point. So go ahead and pick the point that's right above the parabola, the vertex, right? So if the vertex was at negative 3, I'm sorry, at 1 negative 3, go to 1 negative 2. Try this point right here. Let me actually do a different color. Let's go with blue. Okay, so we're going to use this as a test point. Oh. Okay, so when we test, let me zoom in here. This test point that's 1 negative 2. Okay, so let's plug in. That'll be negative 2 greater than or equal to 1 minus 1 squared. Oh man, what happened? Okay, squared, let me erase this, and then minus 3. Okay, so simplify here, that's going to be 0, right? 0 squared is still 0, so this all goes away. So ultimately you end up with negative 2 is greater than or equal to negative 3. Basically, is negative 2 bigger than negative 3? Yes, negative 2 is greater than, because it's a less negative number. Okay, so then that means you get to shade everything in green that is inside, right? Inside of the green parabola. So that represents all of this. Okay. All right, so notice, right, there's an overlap. There's a little bit of an overlap where the red and the green both share some space, right? It's right in here. Let me highlight it. It's right in here. Okay, this is what we would call right there the feasible region. Okay, so notice how now it kind of all connects. It's what we were doing at the beginning, but now you know how to graph the quadratic. You know where to shade on the quadratic, and now you can then combine where the quadratic and the lines have overlapping space. Okay, that's where they have overlapping space. Okay, I'm gonna skip these two for now. They're not as important. Okay, this won't really show up on your test, so don't worry about it. The important part is, can you identify the area, right? And then can you list it out, right? Highlight it, point to it. Tell me this right here represents feasible region. Okay. Light blue is kind of hard to see. All right, so last one here. Let's take a look at example 6. Okay, so pretty straightforward. Actually, no, we're gonna skip 6 actually. So again, I'll finish this one up and I'll post it in the notes. I want to get to the next part, which is the constructive response. Okay, so you'll see something like this, like maybe like one problem on your test. Okay, most likely like example number 5. Okay, that's the big one. Okay, you'll see something where you have a couple graphs. You have to identify. You won't be asked to graph. The graphs will be there for you. You have to identify where is the overlapping section. Okay, that's the important part for you to be able to understand. Okay, you can check how you know whether you got this right or not. All right, so let's move on. Let's take a look at the other one that I wanted to use. Okay, so give me a sec. I'm gonna pull it up right now. Or actually, no. Okay. Okay. All right. So this is going to be don't want to close that. All right, so this will be the big thing that for sure shows up on your test. Okay, this will be, you know, like the last page where we always have some sort of constructive response. This is essentially it. All right, now it's not too bad. It's actually pretty easy. Most of the questions are pretty doable. Okay, so let's take a look. So for this one, let me actually fix this. This should be negative. Okay, why can I not edit this? Hold on. Oh man, did I close it? Give me a second. I accidentally closed something that I needed. All right. Okay, this should be good now. Okay, so this actually should say negative. This should say negative. This should be negative as well. All right. Okay, so take a look. So you got a number of subscribers for 2 websites can be modeled by the equations below, where X is the number of days since the website's launched, right? Okay, so if you look down here at the axes, right, what it represents, you have the number of days since the website was launched. So think of this here representing as the day 0, right? The first day that it launches, or like the first moment that it launches. And then it goes in terms of 1 day at a time, okay? And let's see. So you have 2 different websites. One website is modeled by a parabola, right? That represents this one, right? You can clearly see which one that is. That's your U shape. And then the other one, again, it's just a line, right? You have X, you have Y. X is to the first power. So you can see how this could become a line. You would just have to shift it around a little bit. But again, you don't have to at this point. You just have to identify which one is which, okay? So then it asks, when is the number of subscribers to each website the same? Well, this is where you got to think about, okay, what does it mean for things to be the same, and where does that show up on the graphs, right? Well, it's typically in like special points, right? It's the points where the 2 graphs intersect, right? So if I have an intersection between the 2 graphs, that's going to represent a time when 2 things were the same, okay? So when is the number of subscribers to each website the same? When, right? When is it? That means what day, right? What day after the launch were they the same in terms of subscribers? Okay, so you want to answer that question, right, by saying that the number of subscribers on, there's 2 different days, right? So if you look at point B, that's telling you that this point right here represents 1,320, right? Well, if the X represents the number of days, well, then the number of subscribers is the same on day 1. And again, over here at point A, over here though, that's 34, 1310. Okay, so on day 1 and day 34, okay, that's when the 2 intersections take place. Okay, so that's when they're the same. All right, so now you can add more detail, right? You can say that on day 1, right, on day 1, 320 subscribers, on day 34, 1310, right? Obviously, the more detail, the better. But the important part here is to explain the reasoning. How do you know, right? How do you know that they are the same number of subscribers on day 1 and day 34? Well, it's because that's the points of intersection. So you have to be very clear about that. You know that that's when they are the same because that's when the two graphs intersect. Intersections mean that they are equal to each other at those points, okay, on those days for those x values, okay? So the two graphs intersect at the points when x equals 1 and x equals 34. Okay, so that's an explanation of your reasoning. You're telling me you understand that the subscribers are the same. The subscriber is represented by the y value, right? So on day 1 they both have 320, and then on day 34 they both have 1,310. Okay, on those 2 days they have the same amount of subscribers. Okay, but you got to let me know something here that mentions the point of intersection. Okay, so two graphs intersect at the points, right, when x equals 1 and x equals 34. And you've already mentioned that you know that x equals 1 means day 1 and x equals 34 means day 34. Okay, so that's a good enough explanation for that. So really it's just reading the graph. Okay, it's an easy problem. You don't have to do any real math there. Okay, all right. Okay, next thing. Here what you want to do for number 2. Okay, let me fix this. This again is negative. All right, so it says to solve the inequality and then to state the solution using the interval notation. All right, so when you initially look at this, what do you think? You think probably I got to solve this algebraically, right? I have a lot of numbers. I got a 33 in the denominator. Maybe I got to try fraction buster. You don't have to do any of that. Okay, this problem, when you solve inequalities, think about what you did on your quiz on Thursday. You use highlighters. You identified which one was which, and then you found where one was bigger or where one was smaller or under the other. Okay, that's what you got to do for number 2. Okay, so solve the inequality here just means use the graph. The graph is there for you for a reason. Okay, so let me erase some of this. And let's go ahead and do that. I'm gonna shut off my camera for now because I'm gonna detach the tablet. Okay, so I'll see you guys in a little bit. All right, so in this case, right, I can see very clearly which quadratic or which equation is which. So I'm going to use a couple different colors here. So I got my light blue. That's going to be my parabola. And do you see how this equation down here looks similar but not quite to what you have here? Right, it's not quite exact. But there's a reason why they look similar. It's because we were able to get from this one here, right, where you have your x and your y. There's a way to transform it to make it look like this one. Okay, which means that it's still the same line that's on the graph. Let me show you how. Okay, the reason why you can't have it the same way is because the first one has a y in the equation. You don't want to have a y in the equation. You want to isolate y, all right, so that you can set them equal to each other, basically. So basically, here's what you can do. You take 990x minus 33y. I'm going to show you how these two end up being the same. Okay, so we can add 9570 to both sides. You get 990x minus 33y. Whoops. Plus 9570 is equal to 0, right? Because this cancels. But you don't want to have x and y on the same side. You're basically trying to solve for y. So you add 33y to both sides. Now you have 990x plus 9570 equal to 33y. Okay, so we're close, right? Take a look at what we have. All I need to do now is divide by 33. So now you can see how 33 ended up being in the denominator. So you end up with y equal to 990x plus 9570 all over 33. Right, so this right here is the same as what's there. Okay, so this is the same thing. That means that this equation, this expression, that's our line, the one that's already graphed. Okay, so I'm going to put that one in green. So right here. Okay, so it's not a trick type of problem. I'm not introducing a different graph. It's the same one. It's just rewritten. Okay. All right, so now here's what we do. You want to know when blue is greater than green. Right? Where is blue greater than green? Well, first draw your sections. Because you have a point of intersection at 1. Okay, at 1, go ahead and put a number line here. Put 1. Now at 1, open or closed? Well, look at the inequality. That's greater than, it's an open circle. Other point of intersection happens where? Right here, okay, at 34. So you put a point, on your number line, call that 34, and again, open circle. And you have section A, you have section B, you have section C, right? Where do you see that blue is greater than green? It happens in section B. So you can go ahead and shade that middle section. Okay. So as part of your interval, right, it's telling you now to state the solution using interval notation. Okay. Don't just give me the graph of the number line. I want the notation too. So in this case, because it's open circle, that's a parenthesis 1, comma 34. All right. So number 2, pretty easy. Just like what you did on your quiz. All right. Now number 3, real easy. Okay. Says to write an inequality, you can use write. Write does not mean solve. You're just writing the inequality. Okay. To find the number of days in which the number of subscribers to website 1 is less than or equal to website 2. Okay. So I just need to use the equations that I have up here already. Okay. I have 2 of them. Okay. So website 1, well, website 1 is the parabola, all right? So that's going to be negative x squared plus 625x plus 256 is less than or equal, okay? So less than or equal website 2. Okay, now with website 2, the tricky thing is that I cannot just include what I have here. It's going to look really weird because it has a y, right? I need to write it in a way that it doesn't have a y. Well, the good thing is, that it already shows up here, right? We already did that work on this side when we found it without y, or where y was equal to it. So you can utilize that one more time, okay? And so now you're going to have website 1 is less than website 2. Website 2 is represented by 990x plus 9570 is less than 33, right? So very similar to what number 2 looks like, right? Take a look at number 2. Here in number 2, you had website 1 greater than website 2. In number 3, website 1, this represents website 1, is less than or equal to website 2. Okay, because it's asking you to write the inequality only, not to solve, then you're done. That's your answer. Okay, you can leave it like this. Okay. All right. So now number 4. Okay, there's a couple of like little typos in here. Let me fix these. Okay. All right. So for number 4, it's actually not written right. Let me actually let me show you the one that is. All right. So you can see number 4. This is what it should look like. Okay. You see, it's an inequality, right? So basically, it's asking us, I want a shade, right, somewhere on this parabola, and then I also want a shade somewhere for this line. All right. So we just need to go ahead and do that on the graph that's already given to us. Okay. So this is a different type of problem from number 2. This number 4 right here is similar to what we did at the beginning, right, when we were shading above and below. All right. So now let's take a look at how we can get through this. Let me take a screenshot of this. And I'm just going to focus this right here. Okay. All right. So the only thing I'm going to change is I'm going to change it to what the inequalities are. Okay. So I'm going to scratch this out. I'm going to scratch this out. So the inequalities that you're given are, let's go back. You want the quadratic here. You want y to be greater than or equal to . And then for the other one, you want same thing, right? You want 33y greater than or equal to. All right, so let's take a look. All right, let me rewrite these. I have y is greater than or equal to negative x squared plus 625x plus 256. And then I also have 990x minus 33y is greater than or equal to negative 9570. Okay, so the top one, that's pretty easy, okay? The quadratic, let me go here with, let's go with blue. Okay, so my quadratic will be blue. I'm going to shade in blue. Okay, so it's above, right? Y is greater than. If I'm greater than, then I'm above. So where is it that I'm above the parabola? It has to be this region here. Everything above the parabola is represented by the blue. Okay, I'm greater than, I'm above it. Okay. Okay, now the line, again, same thing, right? Some of the work that we've already done here, but let's just do it one more time to make sure we get the inequality right. We need to make sure that the y is by itself. So let's go through the work of getting this isolated, right? We want to isolate the y. So first thing we can do is we can subtract 990x. Okay, so subtract 990x on both sides. you're going to get negative 33y is greater than or equal to negative 990x minus 9570. Okay, to get rid of the negative 33, divide by negative 33 to all three terms. Okay, that cancels. You drop the y. Now, because you dropped the y, you divide it by a negative. What happens to the inequality? That flips. Okay, so now this ends up being negative divided by negative. Actually, in fact, yeah, and we're just gonna leave it as 990x over 33 positive, and then this one the negatives cancel, so now you have a positive 9570 over 33. Okay, so notice it's the same thing that we got before, because since they have the same denominator, I could just write it as 990x plus 9570 over 33. Okay, now y is less than or equal to. So if my line is less than, right, where do I have to be? Sorry, where do you have to be less than the line? Well, underneath, right? So it's all of this. Right? Imagine that the line extends, right? Extends further. Okay, so everything in here counts. Right? So you can see that the majority of the intersection is going to be almost like to the right side of the curve. Right? So this area here, right? This piece, all of this becomes feasible region. Okay. All right. Well, that's pretty much it. Are there any other questions that anyone has? I know some of you left. That's okay. Let me know if there's any other questions. Feel free to play the video back and rewatch parts that maybe you didn't quite understand. I'm going to send an announcement out about the test on Thursday. Okay, so for those of you still around, the test will take place on Thursday at a normal time that it would usually take place. So I'm actually going to extend it to give you additional maybe like 20 minutes. So class usually starts at 12:06 or 12:07. I'm going to start the test at 12 and it's not going to end until 2. Okay, so you have 2 full hours. The test is going to be basically a hybrid. You're going to take your test on Edulastic, but in order to receive full credit, I need to see the work that you did to get that answer. Okay, so I will explain and I will send a post on Schoology later with the details, but essentially is whatever response you put, it has to match the work that you're turning in. So I'm still essentially grading it by hand in a way, because I need to look over the work that you did to see you know, how you got your answer. Okay. So in order to submit that, I'm going to go ahead and just create like an assignment on Schoology where you're going to submit like a picture of your work. And I'm going to create a template so that you utilize it. Okay. So spread the word that the test will be on Thursday. I only got a few viewers today, maybe about 16 or so. I think that was the most that I got. That's okay, you know, as long as people watch a little bit later, but let them know, because unless I hear from them, then their test is just going to go as incomplete and they're going to have to take it when they get back. And who knows when we'll be back? We're not quite sure. It could be after the 2 weeks, but it could be after spring break. So that's a really long time to have to remember all of this content. So that's why I don't want to wait too long and then have you guys forget. I feel like you guys do better when it's fresh. So I know it's a tricky situation. So I'm gonna go ahead and put that information out there. All right. So help me spread the word. Let the kids know. Any questions? Send me a message. But have a good day. Okay. It was nice to know you guys were there. All right. Have a good one.